You're falling. There was no warning, no countdown, not even a spaceship hatch hissing open. One moment you're going about your day. The next, this. Below you, an ocean of swirling clouds painted in strokes of crimson, orange, and cream stretches to an impossible horizon. You're staring at a storm so vast it could swallow the entire Earth and still have room for dessert. This is Jupiter's great red spot. The wind here isn't just howling, it's a physical wall of force. At the storm's edge, speeds blow past 400 miles per hour, nearly double the intensity of the most powerful hurricanes on our planet. You're now an unwilling passenger on the most violent roller coaster in the solar system. The horrifying part? There's no ground to hit, no surface to land on, just an endless, crushing descent into the heart of a gas giant. The question isn't just if you would survive. It's what you would experience in the few moments you had left. So could you handle it? Your journey starts in a bizarre, inverted reality. You're not falling towards a surface, you're falling into the sky itself. For the first few seconds, the sheer scale of it all would be paralyzing. The Great Red Spot isn't one single storm, it's a chaotic dance of smaller whirlpools, each one a tempest in its own right, all feeding into the larger monster. After about a minute of accelerating, you'd smash into the first real layer of Jupiter's atmosphere, the ammonia ice clouds. The temperature instantly plummets to a bone-shattering minus 150 degrees Celsius, minus 240 F. It's a cold so profound it feels like a burn. The air, if you can even call it that, is a toxic soup of hydrogen, helium, and the sharp, biting scent of ammonia. This is where the turbulence really kicks in. You're being tossed around not just by wind, but by the very fabric of the atmosphere. Jupiter is the fastest rotating planet in our solar system, a fact that whips its clouds into the jet streams and continent-sized storms that define it. You'd feel like you were caught in a blender the size of a planet. Then the terrifying truth sinks in. You're just going to keep falling. There's no solid ground to stop you. On Earth, the storm eventually passes or makes landfall. Here, the storm is the landfall. You are descending into a bottomless pit, and the horrors have only just begun. As you sink deeper, two forces launch a relentless assault on your body: pressure and heat. Think about this. For every 33 feet you descend into Earth's ocean, the pressure increases by 1 atmosphere. On Jupiter, the pressure builds with terrifying speed. After just a few minutes of falling, you'd be at a pressure level double that of Earth's surface. A few more minutes and it's 4 times as much. You wouldn't just feel this, you would be physically compressed, every square inch of your body squeezed by the weight of an entire planet's air. The only way to survive this would be in a suit built with the strength of the deepest diving submarine ever made. And then comes the paradox. Despite plunging deeper into darkness away from the faint distant sun, the temperature starts to rise dramatically. The crushing pressure is so intense that it superheats the surrounding gases, turning your frozen tomb into a furnace. You pass through layers of ammonium hydrosulfide clouds, and then deeper still, clouds made of water ice, but it's getting dark. Sunlight can't make it this far down. The only light now comes in blinding, violent flashes. This is Jupiter's lightning. These aren't the familiar flickers of a summer storm. These are megabolts, some potentially hundreds of times more powerful than anything on Earth, erupting from deep water clouds and lighting up the abyss around you. You're now hundreds of miles below the cloud tops. The temperature is climbing past the boiling point of water, and the pressure is over 1,000 times what you'd experience on Earth. Communication is impossible. The dense atmosphere absorbs radio waves, silencing any desperate call for help. You are utterly, terrifyingly alone in the dark. You might be thinking, surely we could build a probe to handle this. Well, we've tried, and Jupiter has casually destroyed them. Back in 1995, NASA's Galileo spacecraft deployed a small probe designed to do exactly what you're doing. It was an engineering marvel, built to withstand the extremes we've just described. For 58 minutes, it sent back data as it plunged. It survived the insane winds and the initial brutal cold. But as it descended, the pressure and heat became overwhelming. The probe was first crushed and then completely vaporized. It only made it about 120 miles down, around 160 to 180 kilometers, before it was annihilated. This is why our current champion at Jupiter, the Juno spacecraft, is so careful. Launched in 2011, Juno's mission is to understand this giant, but it does so from a highly elliptical orbit. It screams past the planet, its speeds hitting 130,000 miles per hour, gathering quick snapshots of data before swinging back out to a safe distance. This strategy is essential, not just because of the atmosphere, but because Jupiter is cocooned in the most intense radiation belts in the solar system, which would fry unshielded electronics and deliver a fatal dose to a human in seconds. Juno uses a microwave radiometer to peer deep beneath the clouds. From its data, we've learned that the Great Red Spot is shockingly deep, extending up to 300 miles, 500 kilometers below the cloud tops. That's a depth greater than the altitude of the International Space Station above Earth. These probes are our eyes and ears, but even they can only glimpse the violence from the relative safety of orbit. Let's get back to your fall. You are now deeper than Galileo, deeper than any human-made object has ever survived. You've been falling for over 12 hours. The world around you has transformed yet again. The hydrogen that makes up most of Jupiter's atmosphere is no longer a gas. Under pressure, millions of times greater than Earth's, it has become something else entirely. A supercritical fluid, a bizarre, dense state of matter that's neither liquid nor gas. Falling through it would be like swimming through an impossibly thick, hot fog that is slowly dissolving you. The temperature keeps climbing, reaching thousands of degrees. In the upper atmosphere directly above the Great Red Spot, scientists have measured temperatures of 1,300 degrees Celsius, about 2,400 F, hot enough to melt iron. Down here, in the crushing depths, the heat is even more unimaginable. This is the point of no return. There is no final cinematic crash, no surface to impact. There is only dissolution. The extreme pressure and temperature would overwhelm any conceivable protection. Your body, your hypothetical suit, everything would be torn apart atom by atom. You would simply become part of Jupiter, your molecules absorbed into the swirling, ancient ocean of liquid metallic hydrogen that churns in the planet's interior. Your journey doesn't end with a bang. It ends with you ceasing to be a separate being, crushed and cooked out of existence in the heart of the solar system's greatest storm. So, could you handle Jupiter's crazy storms? The answer is a definitive, resounding no. The combination of hurricane-force winds, toxic air, lethal radiation, bone-shattering cold, unimaginable heat, and pressures so great they turn gas into liquid metal makes it one of the most inhospitable places we can imagine. The very reasons these storms are so deadly are also why they're so long-lasting. With no solid surface to create friction and slow them down, and constantly fueled by the immense internal heat that Jupiter radiates, storms like the Great Red Spot can rage for centuries. We explore places like Jupiter not because we ever hope to stand there, but because they force us to confront the sheer scale and power of the universe. They remind us that our own world, with its blue skies and stable ground, is an almost impossibly rare and precious sanctuary. Jupiter's storms are a beautiful, terrifying reminder of the chaos and grandeur that lies just beyond our reach, a cosmic spectacle best viewed from a very, very safe distance. Exploring these extreme environments pushes the very boundaries of science and our imagination. It's missions like Juno that let us take this impossible journey and reveal the secrets of our solar system. If you find these cosmic mysteries as fascinating as we do, leave a comment and make sure to subscribe and join us as we venture into the next great unknown.